Hey class, so I wanted to take this time to make a video about some of the questions that either I may have not covered in your class or maybe I covered them a little bit too fast and didn't give you all the information that really helps you with these problems. So I'm going to start with number 8 on the review here, and what we want to do is find the exact value of cotangent of negative 9 pi. So let's minimize this and get to our drawing board. So we have cotangent of negative 9 pi. Okay. Right off the bat, I can give you one hint with this kind of angle. What we see is just some number multiplied by pi. So this number could be, for example, in this one, 9 pi, or it could be something like 6 pi, right? Both of these angles are going to lie on the x-axis every time. Whenever you just see a number multiplying by pi, this is going to lie on the x-axis. Because remember, this is 0 degrees or 2 pi degrees, or radians, I shouldn't say degrees, and the negative x-axis is pi radians, right? And when we're swapping from side to side, we're adding pi. So like this is adding pi, and that's adding another pi going back. So any even number, like 6 pi, is going to be on the positive y-axis. Any odd number is going to be on the negative x-axis. So just to fill this out, if it's something like 9 pi over 2, or maybe 5 pi over 2, I'm trying to think. 5 pi over 2 is positive y, and so something like 7 pi over 2. There we go. Okay, 7 pi over 2. So anytime you see an odd number over a 2, it's either going to be on the positive or negative y-axis. So these are going to be on the positive or negative y-axis. So the way you can kind of tell which one it is by simply doing the coterminal formula or something along those lines. You'll have to actually do some additional work to tell which of these two is on the positive or negative x-axis, or y-axis, sorry. But if it is an odd number over an even number, it'll be somewhere on the y-axis, either positive or negative. Okay, so those are my tips on that. So now we can see that since this is an odd number multiplying a pi, that means that this is going to be on the negative x-axis. Okay. Now, once we know that it's on the negative x-axis, remember that in these problems, when we're not giving a position, so let me open up my math lab and type that in just so y'all see what question it asked. So this is on the negative x-axis, and we can submit that. Is correct. And then it asks you to give the coordinates. So remember it's saying, or notice that it's saying r is equal to 1 right there. So when r is set to 1, if we're on the negative x-axis, that's what I wanted to write here, that means that our x is going to be some negative number, and our y is going to equal 0 because we're on the x-axis. So just by looking at our r squared equals x squared plus y squared formula, this is just a Pythagorean theorem. Hopefully you guys see that 1 is equal to x squared, and since x is negative, that means x is equal to 1. So our coordinate system is 1, 0. And I'll go ahead and type that in. So 1, 0. Oh, I'm sorry, I forgot the negative. Negative 1, 0. There we go. Fantastic. So this next question is just asking about the definition. So remember that when you're given an xy coordinate, y is going to always be opposite, x is going to be adjacent, and r is going to be the hypotenuse. So cotangent theta is, from SOHCAHTOA, we know adjacent over opposite, which is x over y. Let me write my negative here. X is equal to -1. I'll just rewrite that really quickly. X is -1. Okay. So since cotangent theta is x over y, we can just evaluate it here. Type it in. We get this is -1 over 0, which is undefined. So cotangent of -9 pi is undefined. So when we type in that cotangent is x over y, it'll ask us to evaluate cotangent of -5 or -9 pi, and we just click that it is undefined. And we can submit that. Perfect. Okay, so that's how we deal with that problem. And you kind of have a similar thing with 360 and any kind of measurement like that. So as far as these questions where it's talking about where your functions are positive or negative, remember the saying, all students take calculus. So starting from quadrant 1, we have all trig functions are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. So tangent and cotangent are positive, and calculus, cosine, and secant are positive. So if it's asking, for example, in this problem, which quadrants is the tangent function positive, we can look at our graph right here and we see that quadrant 1 and quadrant 3 are the quadrants in which it's positive. So we just go in and quadrant 1 and 3 is right there. And that's it. When it gives you two values like this, what we need to do is look at these two conditions and figure out which quadrants both of these conditions are satisfied. So it's cosine greater than 0 and cosecant less than 0. So we have cosine theta is greater than 0 and cosecant theta is less than 0. So these are our two. Okay, cosine, we can look at our graphs and see that the first quadrant is all, so that's going to be quadrant 1, and in quadrant 4 we have cosine, so we have 1 and 4. Cosecant, remember that cosecant is the inverse of sine, so wherever sine is negative, cosecant is also going to be negative. And hopefully we can see that sine is positive in 1 and 2, so sine is negative in 3 and 4. So we have 3 and 4. The only quadrant in which both of these are satisfied is quadrant 4. Therefore, our answer to the question where this angle lies is going to be quadrant 4. Okay. And then we have our last question, which is going to be two conditions, but one of the conditions is telling you the value of a trig function. So in this case, it says find cosecant if tangent is 1/6 and sine is less than 0. So let's look at this. So we have tangent is 1/6 and sine is less than 0. So we already talked about where sine is negative. That's going to be in quadrants 3 and 4. Okay, now that we have these conditions, what you have to ask yourself is, what do these conditions tell you about the sign values of x and y in our coordinates? So what I mean by that is, remember that we can just write down the signs of the points in each quadrant as ordered pairs of signs. So in the first quadrant, our x is always going to be positive and our y is going to be positive. In the second quadrant, we have a negative x, and a positive y. In quadrant 3, we have a negative x and a negative y. And in quadrant 4, we have a positive x and a negative y. Okay. So why is this important to remind you of? Well, if tangent, right, is positive, so tangent is a positive 1/6, but we're only in quadrant 3 and 4. That means that we have to be in quadrant 4. Since tangent theta is x over y, y over x. Since tangent theta is y over x, so let's do a counterexample, right? If this was in quadrant 3, then we would have negative y over a positive x. So tangent would be some negative number. But that's not what we see. We see that tangent is a positive number. So that means tangent must be a negative y over a negative x, which is in fact a positive number, y over x, because a negative divided by a negative is a positive. So with both of these facts now known, we know that x is equal to -1 and y is equal to -6. Now we're looking for cosecant. So before we can fully solve this problem, we have to solve for r. So r is again going to be the square root of x squared plus y squared, which in this example r is going to equal 36 plus 1. I kind of mixed up the order there. The 1 should be where the x is, and the 36 should be where the y is, but I hope you get my point. So r is square root of 37. Okay. Now that we know what our r value is, we can go ahead and evaluate cosecant, because remember, cosecant in our xy coordinate system is going to be hypotenuse over opposite. So that's r over y. So that's going to be r is equal to square root of 37, and y is equal to -6. So our answer that we're going to plug into my math lab, might have to bring it up a bit. And then, okay, you can still see it, cool. So that is going to be a negative square root of 37 over 6. Oh, I did something wrong. I'm sure you guys caught it. So what did I do wrong? Oh, I know what I did wrong. I mislabeled my x's and y's. So tangent theta is equal to opposite over adjacent, which is y over x. So x is actually -6 and y is -1, because tangent is equal to 1 over 6. So this is not a -6 right there. That is a -1, meaning that cosecant theta is just negative square root of 37. Sorry for the mistake on my part. I hope you still understood kind of the process and everything like that. That's what's important. So you can go ahead and try out these problems for yourself, see if you can solve them. If you have any questions, please feel free to ask, and I'll see you next time in class. Sorry guys, I realized I didn't show you me plugging it in and improving that I now have the right solution. So let me go ahead and do that, just so that way you guys are confident that I did it right. We can go ahead and check this answer, and we see that it is correct. So cosecant theta is negative square root of 37.